Hello student, welcome back to my channel Kunal sir at JEE Chemistry World. Today also I am going to represent very important topic as far as JEE Mains is concerned from the plus one portions, which is nothing but a equivalent concept and redox titrations. I am taking a one problem. In that problem itself, different perspective I will explain which help you to solve n number of problems. Let us take that problem directly and look into the concept properly. So here I am taking a mixture, and in this mixture who is there? In this mixture we have 1 mole of oxalic acid H2C2O4 plus 1 mole of ferrous oxalate FeC2O4. This mixture was there. 1 mole of mixture is there oxalic acid and 1 mole of ferrous oxalate, which is required. I am telling the two cases. Case 1. In case 1, what is required? They are telling 100 ml of X molar NaOH required for complete titrations of the mixture. Now this is the case 1 they are telling. Now if you look at when we are giving the NaOH, then it's not a redox titrations. It's a simple acid base titration. Moreover, redox reaction is also acid base in terms of electronic definition. That is different thing. But the thing is, acid base titration means we know common acid base titration means H plus and OH minus will be involved in that reactions. Now if you look at very clearly here, who will give the H plus? Only the oxalic acid. How many H plus? There are 2 H plus, and we know the number of ionizable H plus or replaceable H plus or basicity of the acid is a N factor. So then immediately from here NaOH only react with the oxalic acid, not the oxalate ion. So that's why what I can write down from this reaction, equivalence of NaOH will be equals to equivalence of oxalic acid, which is H2C2O4 oxalic acid. Now if you look at whenever the reaction is fully completed, whatever titration means what? With a known one thing to know the other unknown thing, concentration of a solution. Now if you look at whenever the complete reaction is there, as per the law of equivalence, what we can write down? Equivalence of one reactant will be equals to equivalence of other reactant will be equals to equivalence of product. We can write down, this is the idea. So now if you look at from that point of view, I can write down here NaOH will react only with the oxalic acid. That's why equivalence of oxalic acid will be equals to equivalence of NaOH as per the law of equivalence. Then equivalence equals to what we know? There are two ways we can represent the equivalence. Number of moles into N factor or valency factor. This is number of moles. Number of moles into N factor. This is a N factor. That is nothing but your equivalence. Or some people used to call it as a gram equivalence. Whatever way you call it, equivalence is nothing but a number of moles into N factor. Or another way we can derive equivalence will be equals to given weight by equivalent mass. This will be utilized mostly in electrochemistry. Given weight by equivalent mass or equivalent weight, whatever you call it. And E is nothing but a equivalence or gram equivalence, whatever you call it. Gram equivalence. Now if you look at, we write down from the law of equivalence, the equivalence of NaOH will be equals to equivalence of oxalic acid. Then equivalence is nothing but a, just now we explained, number of moles of NaOH into N factor of NaOH. Clear? So then number of moles of oxalic acid into N factor of oxalic acid. समझा करो यार, N factor of oxalic acid. Clear? Now if you look at the number of ionizable OH minus or number of the ionizable H plus for the acid is nothing but N factor. For the base, number of ionizable OH minus is N factor. From oxalic acid it can give the 2H plus, because you know oxalic acid how it will be dissociate. समझा करो यार, it will give 2H plus and C2O4 2 minus. That's why it can provide you 2H plus, n factor is 2, whereas NaOH can give only 1 OH minus. That's why n factor is 1. Now number of moles of NaOH, how can I change? Because molarity is nothing but a, what do you know? Molarity is nothing but a number of moles of solute by volume of the solution in liter. Number of moles of solute, this is number of moles of solute. Number of moles of solute by volume of the solution is nothing but a molarity. Then immediately molarity into volume of the solution in liter is nothing but a number of moles. So that I am doing the change. NaOH they are telling 100 ml solution and X molar, and they are asking what is the value of X. That is the questions over here. Then immediately what I can write down over here? Then instead of number of moles of NaOH, how can I replace? I can replace the number of moles of, instead of number of moles of NaOH, I can write down molarity into volume of the solution in liter is the number of moles. Molarity is nothing but a X molar into volume of solution in liter. 100 ml means 100 by 1000 into n factor of NaOH is 1. Same way, directly they told in the mixture number of moles of oxalic acid which is there is 1, n factor is 2. You look at only one equation, so one value I need to find out, X value. From this equation easily I will get the value of X. I hope is it clear to everyone. Now from this mixture, suppose they are giving you for this mixture complete reaction is required 0.1 molar and xml of KMnO4 for complete reaction, then they are asking what is the value of X. This is the redox titrations. Now same mixture, when I am giving NaOH, I apply this one. It's a direct normal common acid base titration. We apply the equivalence of NaOH is nothing but equivalence of oxalic acid. Then number of moles they are giving, equivalence equals to number of moles into n factor. We change it. And then number of moles also, from how can I change in terms of a molarity? Molarity into volume of the solution in liter is the number of moles. And then n factor, you know, number of ionizable H plus from the acid is n factor, number of ionizable NOH minus is n factor. We change it and we got that one equation, one value we need to find out. I hope you can do these simple calculations and get the value of X. Now, if you look at same problem they are giving, same mixture, they are telling for complete reaction we require 0.1 molar xml of KMnO4. What is the value of X? Let us look at in the next slide. Now, immediately what the reaction is happening over here? Now, whenever I have a 1 mole of H2C2O4, obviously another data they have to provide you, another data, and medium is obviously this medium. If you look at, they are giving oxalic acid. By default it is a oxalic acid, but still I am telling you it is happening, reaction is happening in acidic medium. This reaction is happening in acidic medium with a KMnO4. Still I am just mentioning to get the clarity about the questions. Now if you look at 1 mole of oxalic acid, you will give rise to 2H plus and C2O4 2 minus. Now whenever it will react with a KMnO4, समझा करो यार, these will oxidizing agent, this will oxidize the oxalate to the what? CO2. This will oxidize, whereas itself will reduce to the what? Mn plus 2 in acidic medium. Now whereas in terms of a ferrous oxalate, what will happen? 1 mole of ferrous oxalate also is there. In ferrous oxalate, iron plus 2 and it will give oxalate. Now here two things will be oxidized by KMnO4. समझा करो यार. Now here iron plus 2 will be converted to iron plus 3, as well as oxalate will be converted to CO2. This point you need clarity for KMnO4, what reactions are taking place over here. Now if you look at here, the oxidation state of carbon is plus 3, in carbon dioxide oxidation state of carbon is plus 4, then immediately n factor we can calculate. What is the n factor? No need to valence. Change in oxidation state into number of atom associated. Always n factor is to calculate per mole of the reactant. So then change in oxidation state into number of atom. Change in oxidation state is plus 3 to plus 4, 1 unit change, and in 1 mole of that H2C2O4 2 unit of carbon is there. That's why change in oxidation state into number of atom. So now here KMnO4 when it is reacting, you समझा करो यार, this KMnO4 oxidize that here both cases oxidation state of manganese is +7 in permanganate. Now here it is oxidizing, iron is +2 to +3. So then here oxidation factor is change in oxidation state into number of atom. 1 unit change, 1 iron atom. Here +3 is going again is +4 oxidation state. Now here oxidation state, change in oxidation state into number of atom. So as both substances undergoing in ferrous oxalate, both parties undergoing. So overall N factor for ferrous oxalate, overall N factor for ferrous oxalate will be equals to, for iron side it will be 1 and for oxalate side it will be 2, which is nothing but a 3. Whereas N factor for oxalic acid side it will be nothing but a, only oxalate is converting to CO2, so which is nothing but will be equals to 2. So now if you look at both cases, manganese +7 is +2, here also manganese will be converted to +7 to +2. So now both cases N factor for permanganate ion, change in oxidation state which is 5 into 1. Here change in oxidation state is 5 unit change, 1 manganese atom, both cases N factor will be equals to 1. Now simply I will apply now here equivalence of oxalic acid plus equivalence of ferrous oxalate, that is a total equivalence will be oxidized by equivalence of KMnO4. That's why whatever the total KMnO4 consumption will be there, that equivalence will be equals to equivalence of oxalic acid plus equivalence of ferrous oxalate. In oxalic acid, who will oxidize? Only oxalate ion, because H plus has a no role in case of oxidation, because already it is lost electron, so that's why further loss of electron is not possible. So now whereas in case of ferrous oxalate, iron will undergo oxidation, ferrous +2 to +3, oxalate also will undergo from oxalate to CO2, both part will undergo oxidation. That's why overall N factor for ferrous oxalate is 3, whereas N factor for oxalic acid side it will be 2. Now immediately we know equivalence will be equals to number of moles into N factor, so that's why number of moles of oxalic acid into N factor of oxalic acid plus number of moles of ferrous oxalate into N factor of ferrous oxalate equals to number of moles of KMnO4 into N factor of KMnO4. Now number of moles I can directly for oxalic acid they are giving 1, N factor is 2 for oxalic acid side, number of moles of ferrous oxalate into mixture 1, then N factor is overall is 3 because 2 plus 1. And now immediately if you look at number of moles of KMnO4, they are telling 0.1 molar KMnO4 utilized, how much volume is required. Then number of moles I can change in terms of a molarity into volume of the solution in liter, and they are giving XML. If you look at the previous slide, they are giving over here clearly what are the KMnO4 consumption was there. That was they are asking in that previous slide. You look at, they are asking 0.1 molar XML for complete reaction. They are asking the value of X. So then immediately we know molarity will be equals to nothing but a number of moles of solute by volume of the solution in liter. So that's why volume of the solution in liter into molarity is a number of moles. That I am changing for KMnO4. Their molarity is 0.1. Volume of the solution they are telling X, XML. So that's why it in liter means X by 1000 into N factor for MnO4 side, which is a 5. Now we got the equation. Then one equation, one unknown. You can solve and you can get the value of X. That's why from this problem we get the entire clarity. Same mixture, if I treat the NOH, what will be the idea we will put. If I give KMnO4, what idea I put over here. I hope I able to give a entire clarity from this important problem. To get this type of more clarity, you should come, like, subscribe my channel so that channel can prosper. Everybody, please join in my channel and look into and get the clarity. Thank you all. Thank you, my dear student. Hope to see you in the next video.